Hi everyone, and welcome to another episode of Get Tech Smart. And if you're new to the show, just a quick recap. I'm showcasing all the great tech that's happening right here in New Hampshire. Today is a little different. Normally you see me by myself, and if you don't know me, I am Flo Nicholas. I am a resident right here in Hudson. I'm a huge techie, and I created this show to help educate the local community and the state of New Hampshire on all the exciting technology. So today, a little different. I have a co-host, and I'm sure some of you recognize him, our own resident right here in New Hampshire, Brian Etienne.
Good morning, Flo.
Good morning. And Brian was actually a guest, and we filmed an episode on artificial intelligence and traffic light management system, and that episode got like a lot of great reviews.
Very exciting stuff.
Very exciting stuff. So today I'm really excited because I recently went to a New Hampshire Tech Alliance event, and it was hosted by a local company in Nashua, New Hampshire called GSSI. And it's very fascinating what's happening right now in the construction industry.
It really is exciting. We're starting to have this marrying of technology with construction services and construction out in the field.
Yeah. So we're not going to waste your time just hearing us talk. So excited to introduce Peter Masters from GSSI. Peter, let's just dive right in. Tell us more about what is GSSI and what are you guys doing in this construction tech sector?
Sure. So GSSI stands for Geophysical Survey Systems. We're a 50-plus-year-old company based in Nashua, New Hampshire. We have about 90 employees. We manufacture ground-penetrating radar technology, and it's used in a wide array of construction projects. And we focus primarily on infrastructure-type things, so utilities, buildings, roads, archaeology, geophysical applications. And so we produce all the equipment right there in Nashua. We have about 90 employees. Everything's done there, research and development, manufacturing, product support, and sales and marketing as well.
So let's dig a little bit deeper, because you mentioned so many areas that you're working on, whether it's like archaeologist or working with construction teams. Now, it's a little different, right? So let's just clear one thing up. You guys are not actually providing services, right? It's actually the equipment, of which you brought some here today.
Yep. Yeah, that's right. So we don't do any service work. We produce the equipment. We train our customers how to use it, and then support them after the sale. So this is a typical instrument that we sell. This is a concrete scanner. It's called the Structure Scan Mini XT, and this is a radar device. And basically, we can use it to scan over a piece of concrete and tell the user where a piece of rebar is, where a beam is located, how thick the concrete is, all about what's inside the concrete. There's a couple of accessories that come along with it. This is called Line Track, which helps them discover if there's electricity in the area or inside the concrete. And then this other antenna is an auxiliary antenna called the Palm XT, which we use to get into tight spaces. We're not always in a big wide open floor. We might be in a stairwell, up against a column, on a beam, in a lot of different positions where it's difficult to use this. But we can connect that small antenna to this and get access to a lot of different places.
So tell me, what would be some reasons why you would want to scan concrete?
So there's a few reasons. Number one, from an engineering standpoint, the engineers might say, we don't want you to cut the rebar, right? That's going to compromise the structure. There may be other elements in the concrete, like post-tension cables, which are under a lot of tension. If you cut them or break into them, they can essentially explode, and it can be very dangerous. There's conduits inside the concrete. There's communications equipment. So if you can think about like a hospital, right? We've got operating rooms over here, and there's a internet connection that runs right through the floor that was placed when they built the building. So running into those types of things could be a serious problem. It's a safety aspect, it's an engineering aspect, and so there's a lot of different things that you want to avoid, essentially.
Flo, I don't know if you know this, but in my industry, I'm frequently working with a lot of different construction firms on greenfield and brownfield construction sites. And one of the challenges we have in our industry is knowing where the utility lines are and, potentially cutting them or causing a problem. The Department of Energy, in fact, says about $40 billion a year is wasted on having to repair these errors. Can you speak to kind of some of those use cases?
Yeah. No, that's a very common use for GPR. Finding utilities is difficult. There's multiple technologies out there that you can use, but none of them are perfect. So using GPR in conjunction with some of the other utility locating technologies can definitely advance the project quickly and safely and more cost effectively. So we can use utilities. It'll be a different machine than this. It's a lower frequency antenna. That means it goes deeper into the ground. So that lets us see deeper into the ground to see where the utilities are. There could be tanks, there could be pipes, there could be steam lines, tunnels, all different types of things that the construction folks wouldn't want to run into. So yes, we can use GPR to find all kinds of buried things in the earth.
Yeah, maybe some gold medallions or something.
I could use that.
I'm here to tell you, beachcombing, right?
Right. Well, there are people that do that too. So,
okay.
Yeah, I mean, it's not a very common thing, but certainly utility location, and there's a big push for it right now. In the communications world, there's a lot of money coming out from the federal government right now to put fiber lines into rural areas and different places that haven't been well served. So there's going to be digging, and there's going to be more of it as the years come on. So
yeah, and I think you touched upon something that is huge right now, which is for us having the background in telecommunication. You work for a tower company, and I worked on the telecom company inside. One of the big things that we're seeing right now is that big push for 5G. Mm-hmm. And with that, it's either you're putting equipment on existing towers, or you're building new towers. So typically what we would hire is engineers on the outside. And I'm pretty sure they'll be the ones that would use this equipment. Yep. What are your biggest clients that are coming in and ordering these products?
So there's actually a wide range of clients. So they could be on the construction side of things. They could be it could be a utility company. It could be an excavation company that installs utilities. It could be an engineering company, like a structural engineering company that's trying to investigate a building or some kind of concrete structure.
Or a tower.
A tower company.
Towers,
yes, we've got those as customers too. So so it could be tradespeople like plumbers, electricians, and things like that. When they're in a building, they're going to be making holes through concrete, and they want to know what's inside there. So there's also a whole sort of range of customers who use our equipment as a service provider for other people. So generally, they'll have multiple different technologies that they can use to solve problems and find things. So they're often customers of ours too.
Yeah, I'm just looking at the cost-effective method to having this type of technology, because you just mentioned $40 billion.
Mm-hmm, exactly. Well, the way I'm thinking about it too is, so let's talk about documents, right? Yeah. So you go into construction on a new site, or maybe you're just building a house or something, renovating a house even. You want to get the original drawings of the property so that way you can understand how things are coming into the property, right? And so today, the way that works is you have to hire a survey person, you have to hire an engineer of record, you have to go to the town hall potentially and find those original documents and hope that they're actually there, or that they were recorded correctly, right? So this type of technology, to me, over time and at scale, can be given to private owners or to towns and cities so that they can better manage engineering work in the future. I kind of envision this as having these digital scans done and putting them into computer models, and then you can have an engineer sitting at their desk in Kansas, nowhere, just at home, not in an office, doing all of these exciting things with documents that are just shared over the internet. Yep. So kind of talk to me a little bit about how the software layer of this plays into engineering today.
Sure. So in terms of software, when someone's using GPR, there's a certain amount of interpretation that happens in the field, right? So there's certain signatures that we look for, and operators will have some kind of a background in the things they're trying to find. So if it's a utility, he should know something about how systems could have been placed, or if it's in a building, some idea of how buildings are be put together. But we can capture data from our instruments and produce a number of different deliverables for customers. So we can make three-dimensional images, like a cube, and then we can draw in different things. So like if you had pipes buried underground, for example, we can do a three-dimensional image of that, draw that in, and then export those coordinates out to a system, a GIS system or a CAD system that someone remote could look at and or store. Same thing with buildings. We can make images of the structural elements inside the building as well that can be saved for future use. I've been doing this for more than 15 years. Most people don't, when I say most people, I'm talking about a city or a town or a utility owner. They may not have great records of where their stuff is. And there is a push now to get that information all captured and digitized, and there's a number of companies working on that.
Data is huge right now. Everybody's talking about data. You know, even when I went to an artificial intelligence summit in London, when I was in London, that's all I'm seeing. Everybody just data, reporting, data analytics. So I'm glad that that's incorporated in the equipment.
Yep.
One thing that I'm really curious about, because there is a huge service aspect here, and I'm really curious why you didn't want to capitalize on that. Instead of just selling the equipment, but doing kind of both, where you sell the equipment and also you provide the services, because that seems to me like a huge untapped area potential for profits for GSSI.
Yeah, well, I mean, that's one way to look at it, but we've always been a hardware manufacturer. So our strength is in the technology. It's how we build the radar antennas, the algorithms that we develop, how we do the mechanical engineering, how building in features that people can use. It's kind of always been our strength. And so, yeah, there is a big market for service providers, but if we were to get into that, we would be competing with our customers. Right? So we think it's better to have more people using our technology than us doing it and competing with other people and trying to keep it closed down.
That's an interesting approach. I mean, I completely understand, because in the wireless industry, it kind of works the same way. For instance, Nokia and Ericsson, they produce, radios, but they're not deploying networks outside of their own. Their customers are, the Verizons, AT&T, T-Mobiles of the world.
Yeah. So we want to build the industry. So, I mean, our company has grown by leaps and bounds, mostly in the last 10 years. But we've been around for a long time, and we really do have the best technology out there, and we want more people to use it. We're also investigating, new ways to use our technology. So, for example, we have a new product called PaveScan, which is used to find the compaction in road asphalt. So there's been a process used over the years to measure the density of the asphalt after they lay it out. And that's important because if it's the right density, it's going to last for a long time and perform as it's expected. But the process to do that has been cumbersome. It's kind of slow. It gives you limited information. But we used GPR to come up with a new method for that. So using our technology, we can cover larger areas. That gives the end user customer, it might be a DOT or a paving company, but they know more about the product that they're putting out there. So the buyer of the asphalt is getting a better product, and the service provider that's installing it is doing a better job. So it's better for everyone that way.
Yeah, and I can definitely see the need for DOT to use this equipment, especially in Boston.
I'm actually aware of a very specific use case. So in Minnesota, there is a very wanted highway that connects two major cities in the area, and when the road was built, the density of the asphalt was not correct in consideration of the way that it freezes and unfreezes in Minnesota. And so what ended up happening is this entire stretch of highway was crumbling to pieces after only 5 years. So this technology can help us get that kind of measurement, ground footprint level of what we're going to need to either first time install or maintain long term, right?
Yeah, that's right.
Yeah, I think that's a great way of looking at it. And as we mentioned earlier too, is just, having worked in the telecom industry, is sometimes you have those situations where you want to add more weight to a tower. And before you could do that, you need to do a verification of the foundation. Can this tower actually manage? Because it's funny, some of these antennas or radios are getting smaller, but they're getting heavier. And definitely in the telecom world, I can see the need for this. And part of it also too has to do with cost effectiveness, right? Is having this equipment and hiring the companies that come to you and buy this equipment, it actually ends up saving, tower companies and anyone else a lot of money because you get that data that would tell you, this tower and the foundation is no good.
Yeah, that's one of the primary benefits of this type of technology is, especially when you apply it to infrastructure, is there's the cost effectiveness is there's a broad benefit across the whole community, right? Everyone pays taxes for the DOT to build roads and pays for their vehicles and things like that. And the better condition that these things are in, the more cost effective it is for everyone.
Creating value, right?
Yeah,
Creating value for citizens, and just here in the town of Hudson, we are currently in large discussions about what our town plan is going to look like for the future. It's being revisioned as we speak. And so what does that entail? It entails, looking at our sewer lines, our water lines, our gas lines, and making a plan for the future of the expansion. And, for towns and cities, the value of this type of technology means spending less money going to outside engineers, for the next 50 to 100 years, because we have 3D model digitized data that we can manage. And, we could also potentially outsource that, and get better costs when we have that data in-house. And unfortunately, today we don't have that data. And so in planning and in zoning, it causes delays.
Yeah, for sure. There's in utility engineering, there's a practice called subsurface utility engineering. And there's a huge cost benefit to using that practice. And basically what it is finding out where everything is ahead of time, verifying it, and then you go to the design stage. So when you're in planning, we need to know what we have first, then we can design something that's going to work for us in the future. So it's a huge benefit on the cost side to know what you have and find out before you start.
Can we talk about the metaverse?
We can talk about the metaverse.
Let's talk about the metaverse.
Okay, so make sure you lead into your thought process of how this connects to the metaverse.
Exactly, let's do that. So the way I see the future of this technology working is we've got engineers who are working from home and they're putting on, their goggles, they're in virtual reality, and they're looking at the 3D forms of what's underground as well as what's above ground, right? And so they're spinning buildings, in a VR, virtual reality, metaverse space where they're actually working for the day. They're picking up pipes and putting them in underground, dragging down electric wires. This is the way I kind of see the future growing. And so kind of speak to me a little bit about your company's vision about the directionality of all the convergence of the technologies.
Sure, so that's something that we're definitely working on. We already produce three-dimensional data. You can see it in sort of a basic three-dimensional format now. And we can export data into other avenues or software products that you can see it and work with it in that way. But yeah, I think our vision is incorporating multiple pieces of data together. So, for example, you could have your utility data for your pipes. You could have some geophysical data about bedrock or water. You could have LiDAR information looking at from the surface. You could have satellite information. You could have geographic information system. A lot of data points coming together in one place so you can kind of see not just a small area 3D, but sort of almost universal on a small scale of, say, the town of Hudson, right? So these are all our power lines. These are our utilities. These are our sewer lines. This is the park, and there's a bathroom here, and there's a pipe that goes out to the sewer line. And all that stuff. So yeah, we're definitely working on that kind of stuff. I think that's going to be instrumental in the future of getting to the point where we have electronic/digital information at our fingertips. I think it's a long-term project, but it's already starting. So
Yeah, I think that's fantastic. I was a little worried when he wanted to bring up that question, so we had to have a little discussion about that. But it makes sense, right? It makes sense. And the other thing that I like about this is, honestly, when I started telecom, it was really difficult for me, and challenging to understand some of the drawings and all this information that we're getting from our electrical engineers that we hired. It makes sense to have these 3D versions, because I feel like anyone will be able to fully see what's going on and understand it. I can see the reports and be able to communicate them effectively to leadership or whoever else, right? So I think that's another thing that we have to think about this is, when people think about construction, they look at construction drawings or anything, they just think, oh my God, complicated, complex. I got to hire someone to take a look at this. But what you're presenting here and what you've just said is, this is going to simplify, right, reporting, especially in the construction industry, which makes it easy for anyone to understand, and not just, just go, oh yeah, let Billy the construction guy look at it. I don't want to look at it, right? Is that kind of like the way you're going as well?
Yeah, that's the way we're going. And we learned a long time ago when we started being able to, when we started being able to produce three-dimensional images, that some people really key into it. So an individual person's perspective, some people can look at the raw data and they get it, right? And then other people, they need to look at it from the side, or they want to look at it at the top, or they want to spin it around, or they want to take other things out of the way, because that helps them understand it. So the tying in with the metaverse type technology it's really important.
Yeah, so it's like cost effective, user friendly, right? And right now there's a big push for just presentations, having the ability to do presentations, not just to your construction teams, but you also have to get the finance people involved and the business people involved, and they want to be able to easily understand some of that data, which sometimes when it's just raw, it looks very scary.
Yeah. Again, it kind of serves the broad public benefit. The more people understand, the better, more momentum you have in one direction to solve a problem.
Yeah. So let's talk Indiana Jones real quick, right? Because if you watch that movie, it was really big on digging and archaeology, right? So one of the things that you mentioned when we first started talking was that this equipment is actually being used by archaeologists and universities doing research. So let's talk a little bit about that, because I don't know, maybe we might turn into Indiana Jones.
The use cases are very exciting. Tell us all about that.
So excellent. So archaeology is a big application area for us. And we have a couple resident archaeologists on our team.
Oh, wow.
They tend to be, and GPR is used quite a bit in archaeology. And they're sort of deep users. So they really develop a lot of important expertise to help us with our products and the archaeology application in general. So typically for archaeology, we're going to use a lower frequency antenna than this, although this has been used recently very successfully. And what they do is you can use GPR to kind of tune in on a specific area to dig, right? So a lot of times in these archaeological sites, there might be a large area to look at, but you're looking at a smaller area. Maybe it's a grave or a foundation or some other type of structure that was left behind. So using our utility frequency antennas, we can scan an area, and typically they'll create a three-dimensional image of it.
Oh, wow.
And that won't show you like an X-ray style picture, but it will show you information of, say, if it was a fire pit, for example, if it was a circular fire pit. We'll be able to see that, and then they can kind of focus in on their digging. They'll know how deep it is, and they can rescan it over and over again as they get closer to it. So it helps find different things before the dig and helps them pinpoint for the dig. Recently, one of our guys, Peter Leach, he used this device down in Jamestown, Virginia, and they excavated a grave.
Oh, wow.
And again, because utility frequency antennas are a little bit lower, they don't have the best resolution, right? So they give you the general picture. But what he did was he used this device, and as they got closer, they were able to produce a very high resolution image of a skeleton. It was a 400-plus-year-old skeleton.
That's exciting.
Yeah.
So
Hope I wasn't related.
So that was kind of a new application of an existing technology, but it kind of like brought the science of it forward. So
wow, this is more fascinating than we even imagined.
Exactly.
Yeah.
I mean, are there any other dig sites that you're aware of? I'm just thinking we might need to go down to like Egypt or something. We can make some money.
Exactly.
So yeah, well, I mean, archaeological digs with GPR have been done all over the world for a long time. So you can imagine across the old world in Greece and Italy and things like that, it's used extensively.
But now the difference is there's a 3D mapping. You can even add an AI and machine learning layer to it to recreate a digitized version of what's underground.
Right.
Very exciting. And for business, archaeology is actually an important part of constructing any new major building, whether that's a data center or a tower, just because before you disturb the land, you do need an archaeology to review so that you can say, okay, we're not disturbing any remains here or whatever. So that's important because it saves money and time by being able to identify that well in advance of any construction
That's
project.
a great point you make.
Yeah, there's a whole industry that's come up around that. It's called cultural resources. And they're used in those situations that you talked about. I mean, very often here in the United States, we're putting in an off-ramp, and then someone comes along and says, you know what, there's a cemetery over there someplace in the woods. And so they need to go find out about that. It's also used quite a bit with Native American tribes. All kinds of indigenous peoples around the world are using it for that
Right.
kind of
The
stuff.
delay period for the State Historic Preservation Office to review can be up to 6 months, in fact. So.
Yeah, it's a big part of a construction project. Yeah.
As a big part, and I'm wondering if just having this available, if that could potentially be able to decrease the time for review, because now, like you mentioned, now you have these models that are 3D models that can really paint a concrete picture of, no, this area is safe for you to move forward with your project, or no, we see something and we need to investigate further.
Exactly.
So.
Yeah, it's an exciting application, and it ties in a lot too with what we were talking about with metaverse type technology, where you have multiple layers. Archaeologists use tons of data. So they have GPR data, but there's other electromagnetic data. There might be LiDAR, there might be satellite shots, there might be geophysical information about the ground underneath it. And so it's helpful for them to bring that whole picture together to get a clear understanding of what they have there.
Yeah, and also, and we haven't really touched on this, and I know we're getting close to running out of time, but oil and gas exploration, too, is a significant, business here. Being able to determine if there are elements in the ground that can be determined that are usually indicators of oil and gas as well.
Yeah, our technology isn't specifically used for deep earth investigations. But certainly closer to the surface where there's utility facilities and things like that, it's definitely a good application for GPR as part of a utility locating toolbox approach.
Yeah. And one of the things that you mentioned is you guys have your research and development team, and I'm sure you're always looking for ways to make your equipment more efficient. Is there anything that you're currently working on now that you're able to share with us? Any upgrades or enhancements to existing equipment?
Yeah, we're always working on new products and things like that. So there's all kinds of crazy machines back there that they're trying to do new things with. There's nothing I can say that's public that would tell you about a new machine, but the pave scanning device that we talked about earlier, that's a relatively new product. It basically came from using the same information but looking at it in a different perspective. And the other thing that we do is we're always trying to bring in better, faster chips. The more data that we can collect and process the signal and look for different things, look at it from a different perspective, and that comes from computer chips and data storage and all that kind of stuff. When you tie those things together, that's really what provides us with a lot of advancements. But also, the idea of this sort of enhanced three-dimensional concept, that's something that we're working on a lot too.
Yeah, and do you get feedback from current customers who purchased the product to say, hey, this is really great, but if you just added A, B, C, D, it would even be better? I guess just thinking about it while I'm talking is, can you customize the equipment based on a customer's needs?
Yes, so our customers can customize the products to a certain degree. We have an electronics box called a controller, and this controller can work with about 8 or 9 different antennas that we sell. And they're different frequency antennas, so they can be used for different applications. So they could use a high frequency concrete antenna to do a building, or they could attach a lower frequency utility antenna to do utilities, or they could go even to a lower frequency to do a geophysical application. So they can customize it that way, so that allows them to investigate different sites or different structures in different ways and get more information. So.
Oh, very exciting.
I've learned so much today. I think I would want to team up with the Archaeologist team because I think that sounds more fascinating.
Summer vacation.
I'm right there with you. So Peter, I mean, this is outstanding. I've learned so much. Like, right? It's like when you think you know something and then you actually have the guests start talking. It's like really mind-blowing. I think this construction technology sector and what GSSI is doing is absolutely phenomenal. So I'm really glad you were here. Any last words for our audience? Anything else that you want to tell them about GSSI?
Well, I just want to say thank you, first of all. But yeah, GSSI is a great company to work for. We've actually been voted Best Company in New Hampshire twice, and second once in the last 3 years.
Oh, wow.
So it's a great environment. It has a wonderful culture. It's exciting work. There's a lot of challenging work to be done there. We're always hiring. So please visit us at geophysical.com. Yeah. We're looking for engineers, manufacturing personnel.
Oh, wow.
All types of administrative positions. So yeah, it's a growing company and it's a lot of fun to work there.
Doing business in New Hampshire and looking to hire right here in New Hampshire, it can't get better than that, right? So thank you again so much for coming on Get Tech Smart. When you release anything new and you want to share it with us, you are welcome back. I'd love to hear more about what's going on. And I don't know, maybe GSSI can sponsor a trip for us to our dig site.
Hey, you don't ask, you don't get, right? Right. Thanks so much for joining us today, Peter.
Thank you very much.
Thank you so much, everyone, for tuning in for this episode of Get Tech Smart. Thank you to Brian Etienne for joining me. I think I might have him come on more often because it was quite entertaining.
It's my pleasure.
Yeah. Thank you, and we'll see you at another episode. Stay tuned.